Alright, these are the test corrections for the test taken on December 12, 2019. How do you know which version you took? This is capital M, lowercase m, th. That's how I spelled math. That tells the different versions. So look at that, and that'll help you explain which one you have. All capitals, or one capital and the rest lowercase. So Mr. Rain going over the Math 5 Chapter 1.3 test taken on December 12th, 2019. Multiple choice, circle the best answer. Question number 1. The graph of x squared is shifted up. This is a d value. And the left is a c value. That is 1. Negative 1. So if I use the formula, y equals a times your function b times x minus c plus d. I don't have an a and I don't have a b, so essentially your function is going to be x minus, but the negative goes here, plus d. So in the formula it has to have a minus sign, so it's going to be x with a minus, there's c equals negative 1. So y equals to the x plus 1, and your d value was 9. Now our function is squared, so essentially it would be something like this. X plus 1 squared plus 9, so that would be choice D. Question number 2. Identify the end behavior of the polynomial function. The degree is 9. This is an odd degree. The easiest one we know is x to the first, and that looks like that. But this is called the leading coefficient, and the leading coefficient is negative. What does this do? Well, it swings the arrows. So now your arrows start up and down now. So if I do that, I have 9th degree polynomials. So if you do a bunch of squigglies and it ends up like this. And then on the x-axis you have positive infinity and this is negative infinity. So the x values go left and right. And here's the y-axis, so that's negative and positive. Now if you need to, you can just write your own sentence and then match it up. This is what we did in class. So we had talked about using this sentence or this box, and then always in there you're always putting one positive and one negative. As x approaches positive infinity, that's essentially just going towards the right. And as x approaches negative infinity, what happens to the graph is you go left. So as I go to the right, it's going down. Down means on the f of x, or the y value, is negative infinity. And as you go towards the left, the graph is going up. Up means positive infinity. So let's match those up. Positive, negative. Not that one. Positive, positive. Nope. Negative, positive. Yes. Positive, negative. That one looks good. Let's double check these. So even in multiple choice, I'm going through every single choice. Negative, negative. Nope. Positive, positive. Nope. Negative, negative. No. Positive, negative. Yes. So my answer is going to be B. Question number 3. Which function could this graph represent? So remember, you have evens and you have odds. And so if you look at my arrows, they're in different directions like this one, so it is going to be an odd. It's going to be an odd. No, that says even, odd. And now it's going to talk about the extrema. The extremas here is one relative max, one relative minimum, so you have two extremas. This one says 3, so that would be wrong. I'm looking for 2, therefore my answer is going to be A. Question number 4. Determine algebraically whether the function is even, odd, or neither. This is the one where the star sub negative x for every x value, and we compare it. So I'm going to put in negative x here. So you'll notice that every x value here, I did that right here. I'm just going to go through and simplify it. So 4 to the negative x 3 times, negative x 2 times, plus 7. So negative times negative is positive, positive times a negative is negative, negative times a positive, negative 4x to the third power. Positive times a negative is negative x squared plus 7. I'm looking at the problem. I'm trying to see if it looks like the original. It's not the original, so it's not even. If I factor out a negative 1, remember factoring out greatest common factors is the opposite of distributing. So now inside here, this does not look like the original. You have a positive, you have a negative, that's wrong, and this one's negative, not positive, so it's not odd. Odd would have been the opposite of the original. Therefore, my answer is neither. And the last choice, which polynomial function, h or p, has a greater relative minimum? So if I draw myself a graph, a cubic function with 3 distinct zeros, 3 just basically means you have 3 dots. It doesn't tell me about its leading coefficient, so I'm going to assume start down, end up. And then I'm just going to connect my dots, shoot throughs. Now, these can go higher, relative max can go higher, and a relative minimum can actually go lower. So here I have something like, going to the y-axis, maybe like 30. And then this one's going to be some negative number. So the choice is, which one is greater, bigger? 30 or a negative number? That would be this one. Now I think I messed up on the pictures. So this graph says p of x, and p of x should be here, but then I put choice B and A. So if you just highlighted this one, that'd be correct. I guess if you clearly identified it's p of x, or you can do the A. But that is the one that has a greater minimum. Alright, so this is the backside of capital MATH. This question says, this was actually taken from the quiz, sketch a set. So the common mistake is students are just going to draw me a polynomial. But this one says sketch a set of functions whose product builds, not a cubic, a polynomial function with the given characteristics. So let's think about a 4th degree polynomial. 4 real distincts. So when it says the distincts, this is basically the number of dots. So let's go ahead and draw the number of dots here. Try to use 4 different colors. Doesn't matter where they are on the x-axis. They can be to the left, they could be to the right. You can split them like I am. And in even degree, the easiest one you know is x to the second. And the end behavior is starting up, ends down. So let's do that. So as I go from the left to the right, I have to go through these. And what happens is basically every time the behavior through the x-axis, either through or bounce, that's called a multiplicity, and that is actually super important. In this case, they have to be all shoot-throughs. So that equals 1. This equals 1, 1, and 1. Now, if you did this, this was the most common mistake. And let me tell you what I would have given you. If you did 2 points, if you just drew some quartic function, if you did the quartic like I just did, I'm going to give you 3 points. It's a common mistake. So quartic with 4 distinct zeros. Let's see if we can see my scoring rubric. Okay, so what you really needed to have, this was the common mistake. Let's label that. And I did draw that because a lot of students, probably about every 1 out of 2 students is having that common mistake right there. This is the common mistake. Red light, don't do it. Here is the green. Let's do it this way. So to do it properly, you could have done, now you still have those same colors, but then you're building it. Sketch a set, many. So you could do 4 linears, would be acceptable. Let's write that. 4 linears, right? A linear times a linear times a linear times a linear equals a quartic. Quartic is to the 4th power. You can also do a quadratic times a quadratic equals a quartic. So let me sketch that one. This is my quadratic and a quadratic. That would be acceptable. Or 4 linears. The extra credit questions. What was the name of one of my children? There they are. Brooklyn, Hezekiah, Hadley, Eloise, Autumn. What's one job I had in high school? Jamba Juice or the library? And then what is something I liked from the beginning of your video? Coke, Michael Jordan, Boba, or Palmarius? Okay, question number 8. Sketch the basic shape of each function on the set of axes given the number of zeros of the function. If not possible, explain. So I have a cubic, so that's going to be power of 3. This parallels x to the 1st, right? These are called odd degree polynomials. And it says with 1 0, so this basically means, I don't know how to say it, but 1 dot or 1 x-intercept. And then a is less than 0. So this is the leading coefficient. And what it does is that instead of having a graph that looks like this, the a less than 1 is that negative sign in front. And what it's going to do is it's going to flip where the arrow is. Okay, so my arrows are basically going to be here. Let's try to highlight that in colors. So here I flipped them because my a value, and it's a cubic function. And then my exactly 1 0, there it is. You can put anywhere in there. I'm going to put it right there. Now pay attention. The one exact 0 means that basically you're going to shoot through this, and then I have to have a turning point or extremis. So you have to have the bump. Why is that? Remember, the degree is equal to the reals plus the imaginary. So if you have exactly 1 0, that's 1 real, then you have 2 imaginaries. So you only have 1 real there, and your arrows have to be this way. So in this problem, I'm looking for the following. I'm looking for a cubic, which is power 3, degree 3. I'm looking for an odd degree, So second. Third thing I'm looking for is the end behavior, the arrows, which is essentially kind of like the leading coefficient. The 4, I'm looking at the zeros, the number of dots. Let's write that, dots. And the multiplicity. That's the shoot through or the bounce off the x-axis. So these 5 characteristics, and let's do this in blue. These are the number of mistakes. But if you did it correctly, you get 5. If all of them are right, let's see if this pen works. Technical difficulties here. You have 1 mistake, or 4 of them correct, 3 of them correct, 2 of them correct, 1 of them correct. So that's how I awarded points. Question number 9. And the entire question number 9 is all 4 points. The graph of the basic cubic function y equals x cubed is shown. Suppose that w of x equals v to the x plus 3. Use reference points and symmetry to complete the table of values. So let's make sure we understand this v of x is just the cubic function right here. And those order pairs are already on here in pink. 0, 0, 1, 1, and 2, 8. So those points are already there. How do you use reference points and symmetry to complete the table of values? So let me just tell you how to graph the pink one by symmetry. Instead of going right 1, up 1, you're going to go left 1, down 1. That's how you get that point. Instead of going right 2, up 8, you're going to go left 2, up 8. This is a odd symmetry, which means that it's symmetrical about the origin 180 degrees. Okay? So the next thing we need to identify is, what does this plus 3 do? Well, the plus 3, if I ask myself some questions, where is it? Well, I'll ask you the questions based on my formula sheet here. See if I can squeeze both of those in. Is the 3 there on the inside or outside? It's on the outside of the parentheses here. So is it an A, B, C, or D? Well, it's to the outside of the parentheses to the right, so it's a D value. My D value is equal to 3. If you look at D is greater than 0, it's a vertical shift up. So basically this is going to be shifted up, shift up 3 units. Now, if you take this formula here, it tells you what it does. We have no B, we have no C, we have no A, so the D value affects the Y coordinates. Let me write that formula. X, comma, Y plus 3. The reason why I put a plus 3 here is because we know that this is your D value. So you're going to basically take the original coordinates, and all of the X coordinates are going to be exactly the same. 0, 1, 2. And now I'm going to take the Y coordinates and add 3. So this is, my Y coordinate is 0. 0 plus 3 is 3. 1. 1 plus 3 is 4. 8. 8 plus 3 is 11. Let's go ahead and graph those points. So 0, 3. 1, 4, and then 2, 11. And if you realize what's happening, let's see if we use different colors. Try to use green. All of these points are just going up 3. Do you see that? you can just predict where this one's going to be. 1, 2, 3, right there. 3 points above what was previously. 3 points here, right? 1, 2, 3. So if I draw mine, let's pick a nice darker color. Let's pick purple. So this would be something that looks like this. It's just going up 3 units. So from either the original 5 points, you can just count up 3 units. And that's my graph. Or from the center point, from the origin, right 1, up 1. Left 1, down 1. Instead of going right 2, up 8, from here you're going to go left 2, down 8. And that gives you that coordinate there. I'll give you 2 points if you, for some reason, said that the coordinates go down 3 units. That's wrong, but I'm going to give you some partial credit. And then the last question. Write 2 different cubic functions. Write means like equations. And it says as a product of functions. So product just means multiply. They multiply like parentheses, but don't multiply them out. Okay? Okay, so what you need is, let's see if we can do it in a super obvious colored green. They call this one intercept or factored form. And it looks something like this. Okay, you might be asking, how come I have 3 of them? The reason why I have 3 is because it says multiplicity 2. Multiplicity 2 basically means you have 2 of them. So essentially what I'm going to do is going to put each of these, and because they're the same identical one, I'm going to put them there. And the last one just goes right there. So let's fill it in. So I could put minus 4, positive 2. So if I clean this up, x plus 4, and x minus 2. Now if you put those together, you'll have y equals x plus 4 squared x minus 2. This would count as one equation, either of these. So I'm going to write the word or. If you got one of these correct, then I would give you 3.5. I wrote here on the scoring rubric, 1 correct, 3.5, and that's actually generous because last time I only gave 3. Now, the trick I taught you to get the second one is you can just double what's inside. So you can do something like this. 2x plus 8, because that's double, right? 1x doubles 2. 4 times 2 is 8. And then you can do 2x minus 4. The reason why this right here would not count as writing 2 different ones is they're the same. What's different about these, if you factor out a 2, that becomes your a value, and it does is a vertical stretch. The big idea is that the graph is actually in the same x-intercepts. Let's see if I can punch that in really quickly. X plus 4 squared, and then x minus 2. As I'm punching this in, the common mistake is probably going to put x minus 4s, and then maybe an x equals 2. They didn't realize that the formula has x minus. And then 2x plus 8, and then I doubled that one, 2x minus 4. And what I want you to notice is that the graph is going to have they're both going to cross through the same x-intercepts, right? Multiplicity 2, there's a bounce. Sorry, let me do this really quick. So here's the first one. There's the bounce at -4. And then shoot through at 2. And here comes the red. Same thing, bounce, and still goes shoot through. That's the big idea. So it doesn't matter if they're not exact on the red and blue. What it does matter is what happens at the x-intercepts. So all of question 6 was 4. Extra credit 2 was 0, 4. This whole question here was out of 4. And then the bottom right one's out of 4. So that was 16 points. And then 16, 10 plus 16 plus your name and period, it's out of 28 points. Hopefully for you that was helpful to understand how to do the transformations, characteristics of polynomials, and comparing them.
I love math.